Hello all, welcome back to our Aislyn Technologies YouTube channel. Today we're gonna see about bone tumor detection using image processing AI tools. I'll explain the abstract first. The abstract discusses the critical need for early detection of bone tumor, a type of cancer caused by abnormal growth of cells. It emphasizes using magnetic resonance imaging, that is MRI, as the primary input for the detection process. The workflow includes pre-process the MRI images, extracting relevant features, and then utilizing a CNN, that is convolutional neural network, to classify the image into tumor and non-tumor categories. The CNN is noted for its high accuracy and performance while minimizing loss, highlighting its effectiveness in medical imaging classification tasks. In introduction, it highlights the significance of bone cancer, emphasizes its pre-relevance as a third leading cause of cancer related death among individuals under 20 in United States in 2016. With about 3,500 new diagnoses in 2019, it identifies common bones malignancies, including different kinds of tumors such as osteosarcoma, osteosarcoma, chondrosarcoma, and evening sarcoma, alongside being tumors such as radiographs and then osteoma, enchondroma, osteochondroma. The radiographs are noted as a primary imaging modality for assessing bone lesions, as they effectively provide information about the lesion location, the internal structure, that is margins, and any associated reactions. However, introduction also point out the limitations of radiographs, such as challenging in visualizing certain structures, superimposition, difficulties in different between bone tumors and infection like. Furthermore, the presence of pathologic fractures can complicate the diagnosis by affecting fluid levels around the lesion, particularly in wheezing conditions. Overall, this context set the stage for the need for more advanced image technique to improve diagnosis and differentiate of bone tumors. Yeah, our problem statement is the critical challenge of accurately diagnosing bone tumors at the early stage. This is essential for effective treatment and improvement patient outcomes. Bone cancer, particularly among younger populations, is a serious health concern. With various types of malignancies such as osteosarcoma, chondrosarcoma, and evening sarcoma posing significant risk. Despite the useful of radiographs as a first line imaging method, there are notable limitations in this approach, including diagnostic challenges, differentiate issues, and presence of pathological changes. Here, our objective is to do early detection, and we have for the well-precision accuracy bone localized of the bone tumor within medical images, and assisting diagnosis, improving patient outcomes, and reducing workload and time. Improving patient outcomes and reducing workload and time. Yeah, these are methodology we have used. First, you have used data collection and pre-processing. First, you have done data collection and pre-processing, and then image segmentation using various techniques. I'll explain you the code. Yeah. This is how you train our data set. This is our full data set. We are doing task validation and final training and finally evaluation. Here, the classification is whether it's a abnormal or normal or a tumor. It will classify whether abnormal or tumor. Now I'll show you the training code. Before that, I'll show you our data set. Yeah, this is our data set. Elegant and then normal. Now, what I'm going to do is this is our training code. Here we have used two models. One is V16 and another one is CNN. In V16, then finally, we'll compare the both models' accuracy. Here, we got the trained model CNN as a good accuracy. I mean, here we got a trained model as a good accuracy than VG16. Here we have compared here so that we can tell that so with that we can conclude our trained model CNN has a better accuracy than VG16. So we are saving this. Now the saved model will be dumped into our that saved model will dump into our final code. Yeah, this is our final code. Yeah, I'll run this along with GUI. Will explain the code so that you'll have good understanding of this. First, we are creating a main frame. This is a main window frame, and we are doing this as bone tumor reduction as a title. And these are the labels of this. And here we are creating four buttons. One is for load, reposing, segmentation, warning. For load image, it will go to here we are creating four buttons, load image, reposing, segmentation, pick. So you can see we have four images, four buttons, and then each button corresponding to each function. In load function, it will load an image based on this by using CV2.image read. We are loading the image here, and the loaded image will be transformed into an array format by using image function, and then the self array will given into a photo image function to resize it, and then it will be given to the render. So it will be come as here. Likewise, it will be done like this. I'm giving in our data set, I'm importing any of the images from like that. Yeah. Now first process is done. And what I'm going to do is we are going to do pre-processing stuff. In pre-processing, what we are doing is we are doing sharpened here, and then we are converting the sharpened image to grayscale image. By this grayscale image, we are getting a entropy value, that is Shannon entropy. Shannon entropy is nothing but it's a measure or a value of something in the MRI scan. It's a features that is extracted from Shannon entropy. It will be extracted from grayscale image only because it's a binary image, so it can be extracted from it. So we have named it as entropy value. From this entropy value, we are taking the entropy value here, and then using the same entropy value, we are printing energy of this, and then we are using the sharpened image, using skew algorithm, skew function. We are using grayscale image. We are taking skewness value, and in the same grayscale value, we are importing a contrast value. We will print out here. And then segmentation, our pixels will be our histogram of pixels in a segmented image will come like this. Here we are doing first scan image, and then by using Greco matrix, we are extracting our GLCM feature here, and then based on our GLCM feature, we'll name it as homogenetic. And the respective homogenetic image will be the respected image of its homogenetic will be printed here. Here we have give a function of Greco matrix. It's nothing but it's implemented from sky measure. It implemented from skykit image, which is import Greco matrix. By using this, we are importing our GLM features, and by GLM from this, using our gray corps, uh, we are taking the feature, this homogenetic feature. We are taking this, and we print the homogenetic feature here. And then finally, it's the classification. By using our trained model CNN, we will classify our given image here. Yeah, now I'll show this data. So now you can have some clear idea on this. After load image, we are doing pre-processing. The entry processing, the respected image entropy, energy, skewness, and contrast, and segmentation. Yeah, actually index, the segmented the original image, so segmented image, and predict. Yeah, the predicted image is normal. Yeah, this is our load image. And then this is where we processed segmentation. Segmentation After segmentation, these three images will be evolved, and then finally we should predict the predicted images validate. Yeah. Thank you for watching our Aislyn Technology YouTube channel. For more Python videos, you can follow our channel. If you have any doubt regarding this project, you can comment below, and don't forget to like, share, and subscribe. Thank you.